Hello, dear candidates. Good day and welcome to lesson 5B of the A-level series titled the GCE Math Panel and Math 24 Super Channel. The previous lesson was a domain on functions, and we continue in this lesson with the range of functions. Please make sure you follow this lesson to the end and don't forget to click on the subscription button so that whenever we release any new lesson, you can actually be notified in time. You can equally have these lessons by going online and clicking GCE Math Panel classes online, and you'll be led to a blog where you can have the notes to this lesson, past lessons, as well as tutorials and quizzes. Welcome, stay tuned. Don't forget to subscribe and share and leave your comments. Let's begin. The range of a function is the domain of its inverse. The range of a function is the domain of its inverse. In the lower classes, we looked at the inverse of a function, and if we have that inverse of a function, the domain of that inverse is what gives us the range of a function as it is termed. It is the set of all the images as well. To find the inverse of a function, or solve for x, as it is also called, and finding the value of y for which x is defined are the steps involved in getting the range of a function. So the first thing is to find the inverse function, or we solve for x, and the second thing to find the values of y for which x is defined. In short, the range of a function is the set of values of y for which x is defined, unlike the domain, which is the set of values of x for which y is defined. So let us take an example. Example 1, determine the range of the following functions. The first function is f of x equals 4 plus 3x. So the first thing to do here is to look for the inverse of this function, and recall, to get the inverse of the function, we start by saying let f of x be equal to this y. Therefore, this will give us y to be equal to 4 plus 3x. In this question, we are solving for x. So from here, x will be equal to y minus 4 on 3. So what are the values of y for which this function will be defined? This function x will be defined for all values of y. So the range is the set of all real numbers. So this function will be defined for all y values in the set of real numbers. That's the range of this function. Another example, we have 4x equals 2x plus 3 plus 1 on 3 minus x. To get the range of this function, we start by saying let this h of x be equal to y. Solving for x here will give us 3 minus x times y will be equal to 2x plus 1. We expand and bring like terms together, and we will end up with x being equal to 3y minus 1 on 2 plus y. So the range of this function is such that the set of all real numbers such that this denominator should not be equal to 0. In this case, you inequate 2 plus y to 0, and y should not be equal to minus 2. So y should not be equal to negative 2. So the set or the range of this function is the set of all real numbers, excluding the values for which y is equal to negative 2. Let's take more examples. Okay, let's take other examples. Example, find the range of the function given. We have x squared plus 4x minus 5. We have to look for the range of this function. And the first thing to notice here is that this function is a quadratic function. And the easiest and fastest or possible means to solve this is by completing the square, since it's a quadratic. So let's complete the square. So let f of x be equal to y. We'll have y to be equal to x squared plus 4x minus 5. I want to complete the square. So the coefficient of x squared is 1, because the first thing is to divide all through by the coefficient of x squared is already 1. I'm going to add a half of the coefficient of x squared on both sides. I'll add it and subtract so that I leave the equation unchanged. This is completing the square method, okay? If you have issues with this, you go to back to chapter 1 or chapter 2 rather, and you see how completing the square was done with quadratics advanced level. So a half of 4 is 2. We will square that 2 and add it. So this first section, we have completed a square here. But after adding these 2 squared, we have to subtract it to make this equation to remain what it is. So nothing has been changed, as you can see. So this part now inside the square brackets is actually a perfect square, because this x squared plus 4x plus 4, which can be written as x plus 2 all squared. So it's a perfect square. So it can be written as y equals x plus 2 all squared. And then this other section, we can simplify. This will give us minus 5 minus 4, which is minus 9. From here, we can easily have a y. So y plus 9 is equal to x plus 2 all squared. Solving for x here, we first of all look for the square root for both sides. We have x to be equal to the square root of y plus 9. And this square root is a positive or a negative square root. So minus 2. Now, whether it is positive or negative here, the most important thing is that this y plus 9 should be strictly greater than 0, or should be greater than or equal to 0 rather, because the square root of 0 exists. So y should be greater than or equal to negative 9, because negative 9 plus 9 is 0. So the range of this function is a set of all real numbers, excluding the values of y strictly less than 9. Equally, if you sketch the graph of this quadratic, you can equally see that because this negative 9 is the minimum value of y, therefore means that all the other values of y are greater than 9. This is the quadratic that has been sketched. So you can see that y ranges from negative 9 to positive infinity, right? So this equally is what the range has told us using this completing the square method. So you can equally look for the minimum value whenever the function is a quadratic, or the maximum value, and from there you can determine the range. The coefficient of x squared in this equation is positive, therefore this our function is going to be a value shape or a cup shape, as you can see, a u. So we therefore know that this negative 9 here is the smallest value. All other values are greater than negative 9. If the coefficient of x squared here was negative, then you expect to have a hill. In this case, our negative 9 here was going to be the maximum value, and other values will be smaller than negative 9. Take note of this. So another thing is that you can equally use differentiation to find it, and using differentiation, we'll be actually be looking for the maximum or minimum value, as I've just explained. Another example, guys, h of x equals the square root of 3 minus x to find the range of this function. So let our x, our y be equal to h of x. We square both sides. We will have y squared to be equal to 3 minus x, and x to be equal to 3 minus y squared. Normally, this is a polynomial function, and the range will just be the set of all real numbers, because no matter the value of y, x will still be defined. The range is a set of all real numbers. So normally, if you ask the inverse function, recall that is how you write the inverse function. It's important if you can state this inverse function first, and then before you state the domain as well. That is the domain of this inverse function, which is also called the range. That will not be an issue. Let's take 1 over e to the power x minus 1. This is a good one. So let y be equal to h of x. From here, we'll have y to be equal to 1 over e to the power x minus 1. Multiplying all through by the denominator, we obtain y e to the power x minus y equals 1. This will give us y e to the power x to be equal to y plus 1. And dividing all through by y gives us this. So x will be defined for values of y excluding y equals 0, because the denominator here is y. So this y should not be equal to 0, otherwise this function will be undefined. But we have not completely solved for x. So many students will end at this point, and this is the problem. Do not stop here. To get this inverse function, we are solving for x. So what do we do at this step? From chapter 1 of this pure math A-level series, you know that to solve for x here, we have to take ln on both sides. We're taking ln on both sides because the base here is e. That's the advantage. So when we take ln on both sides, we have x to be equal to ln y plus 1 over y. And from here, we can get the domain of this inverse function by using the number line, or you can equally use tables. And the condition is that this y plus 1 on y should be strictly greater than 0, because the ln of negative numbers is not defined. Another condition is that y, the denominator, should not be equal to 0, as you have already seen. So -1 and 0 are not included in these boundaries. Now let us test let us test the different regions to see the values that we have. If we test between -1 and 0, we can take -1/2, for example, and fit in this function. We are going to have -1/2 plus 1, which is which is +1 plus 1/2, and -1/2 as a denominator. When you say +1/2 divided by -1/2, is going to give us a negative number, which is not, of course, greater than 0. Therefore, this region does not satisfy. When we take other regions, either above or below, let us start with below. If we take any number less than -1, -2, for example, we have -2 plus 1 is -1, and negative over -1 is going to give us a positive number, which is greater than 0. Therefore, the region below satisfies. Equally, if you take a number, a value above 0, then we are equally going to have values that satisfy. Therefore, the range of this function is a set from -infinity to +infinity, of which -1 is, and the interval from -1 to 0 is not included in this domain of definition. And you equally have this other function, lindat. So forget about the squaring both sides, it's a typing error. So we have this, and when we solve here, we are going to have the value of x to be equal to 0.5 into e to the power y plus that. And from here, we see that this function x is defined for all values of y. So the domain of this function is the set of all real numbers, the set of all real numbers. And if we have equally e to the power x over e to the power x minus 1, and we solve as well, just like the previous example, this is what we are going to have, the ln of this. And in this case now, the denominator should not be equal to 0, numerator should not be equal to 0, and we can use these tables to test as well. Boundary solutions being 0 and 1 still, and values between 0 and 1, you see that you will not still satisfy, because if you take a half, for example, and fit here, you have numerator will be positive, denominator will be negative. Positive divided by negative is a negative number, which is not greater than 0. Therefore, this region between does not satisfy. We see that the regions below 0 and above 1 both satisfy. Therefore, the range of this function is a set of all real numbers from -infinity to 0 from below, and 1 from above to +infinity. Advanced level students take special note of these questions, because they like to ask these questions at advanced level and baccalaureate. Thank you guys so much. There are a couple of exercises here for you to look for the domain of the inverse functions, also known as the range, which can apply all of these concepts already learned, and it will be very easy. Don't forget to subscribe to this video, and if you have or need more material, just go to gcemathpanel.com or GCE Math Panel Classes Online, or www.gcemathpanel.blogspot.com to join our live lessons on Sundays, or to send your questions. Just go to gcemathpanel.blogspot.com and you submit your question there in the link in picture form, which we are going to give the answer online, which you can watch as a video. Equally, we have past questions and sample papers for you to prepare for the GCE. We have monthly mocks online, which you can visit the blog to help yourselves to with studies. Thank you so much. We have been Maths24 Super Channel and the GCE Math Panel. Stay tuned, and the next lesson is the parity of functions.